The condenser coil is a series of piping with a fan that draws outside air across the coil. As the refrigerant passes through the condenser coil and the cooler outside air passes across the coil, the air absorbs heat from the refrigerant, which causes the refrigerant to condense from a gas to a liquid state. The high-pressure, high-temperature liquid then reaches the expansion valve. A thermostatic expansion valve (TXV) is a refrigerant and air conditioning throttling device that controls the amount of refrigerant liquid injected into a system evaporator based on the evaporator outlet temperature and pressure. Expansion valve lower the pressure and temperature include controlling the flow of the refrigerant to the evaporator. There are three different forces at work in TXV: bulb pressure, spring pressure, and evaporator pressure. Bulb pressure comes from the bulb that is mounted at the outlet of the evaporator. The bulb sends the suction temperature and drives the diaphragm down if there is an increase. Spring pressure is constant and pushed up against the diaphragm, counter to the bulb pressure. The spring pressure is calibrated when the valve is set by the equipment manufacturer or the installer. Evaporator pressure pushes the diaphragm up when the suction pressure increases and comes from the evaporator load on the system, which varies according to different operation conditions such as room temperature changes. Based on the balance between these three pressures, the valve will either open or close. The evaporator coil is a series of piping connected to a furnace or air handler that blows indoor air across it, causing the coil to absorb heat from the air. The cool air is then delivered to the house through ducting. The refrigerant then flows back to the compressor where the cycle starts over again.